Now, this is a topic which doesn't have ready-made material available. How to talk on this, how to give guidelines. So what I want is that let us make it very interactive, because you are all in teaching and you all have experience. So let us share the experiences through this platform which we have got today because of Professor Gupta's efforts. Many of you must be already guiding projects. You have also done projects during your engineering and diploma programs. So let us share the experiences. What is the percentage of percentage weightage to the project in engineering college? Anybody? In terms of credits? And anybody who can tell me what is the Madam Parul Chawla, you have any idea how much is the percentage weightage to the project?
सर मुझे एक्चुअली परसेंटेज का आइडिया नहीं, लेकिन रिसेंटली वी आर एडिंग minor project in our curriculum, in our diploma courses.
Okay. That means percent that weightage will be more than one major project and one minor project. Anyway, what I estimate is that almost 10% of the total credits are given to the project work. So 10% is a huge weightage which we should concentrate. And project work deserves that weightage and deserves that seriousness in your academics. Let me start my presentation. So I have not written a session on student project identification and planning. Intentionally, I have written it as a discussion with you because you are all doing all this. So anybody coming just for the lecture cannot give you any new guidelines. Let us say the guidelines will come out of the discussion we will have. This is my current Gmail and mobile number. If somebody wants, they can note it, and so that they can be in touch afterwards also. So what actually student project work is? Why do we have the student project work? We are teaching, let's say in engineering, we keep teaching for 3 years, theoretical aspects to the students, of course, coupled with practical classes also. But that application part, we are not doing anywhere. So project is basically applied part of what you are doing. The project work is an important tool for both instructing students, that means teaching, learning the students, and assessing whether students have developed critical knowledge and skills for college and career success. Whether they will be able to apply when they go out in their employment, whether they will be able to apply what they have learned during this period, that is the basically aim. One is you focus on this, tell them how to apply, and second, you know whether they have developed. You can assess, because after the project is there, there's a assessment of the project. So what you do is you critically review what they have done. Now I'll come to that, how to assess the project work, because project work is not just sitting with the student and giving marks. There should be a proper method of assessment of the project work. So in the project work, students have the opportunity to explore their interest. There are many areas in each discipline. Let's say computer science. Somebody wants to do development only. Somebody wants to do, let's say, AI. Somebody wants to do machine learning. Somebody wants to do cyber security. Somebody wants to restrict himself to the basic programming. He says, I'll develop as a programmer only. Of course, programming will be needed in AI, deep learning, machine learning, cyber security also. But they can choose what area they want to explore. In that area, they can take their project. Students learn the knowledge, skill, and attitude related to 12 questions. When they have to do project, they have to ask questions. Ask question to whom? To themselves, to their peers, to their teachers, to the persons outside the college, maybe industry people. So they will ask questions. They should be prompted to ask questions, like I am asking you to please discuss, ask questions. Then find, sort, and evaluate information. First is read widely and deeply. They will know where the information is available and how to go deep into a particular topic, because they have, in the first step, they will first focus on a particular area. In mechanical engineering, I can go for manufacturing, I can go for thermal engineering, I can go for management. Even within that areas, in manufacturing areas, I can say I will work only in additive manufacturing. In civil engineering, people can go for structural design, they can go for soil engineering, they can go for road technology, whatever you call it. So they decide the area in which they want to go further. So then they will find out where the information is available, what are the standards, what are the national and international standards which have to be followed for giving the solutions. Then they should be able to find, sort. They should be able to sort. Sorting means putting in some separate groups. That means, okay, they have found the information on structural design. Maybe they want to work on the cement concrete work, or somebody wants to work on the metal, or somebody wants to work on both the things. They will sort out the information in different groups and evaluate the information. They should develop that habit. That habit should be inculcated in them, and then they should be able to use that knowledge. That is the aim. Third is analyze, think creatively, write in different forms, problem solving, and communicate results. That means they should be able to analyze things. Something is coming to their mind, they should be able to analyze that, whether it is scientifically based on the scientific principles or it is only hit and trial. Hit and trial may not work now. It has been working. So they should be able to analyze in terms of the feasibility, in terms of the technology available, in terms of the cost analysis, how costly it will be in terms of the societal effect in terms of the environmental effect. All that they should be analyzed. Then they should be able to think creatively. Creativity is the need of the hour. People should think creatively so that they can create something, they can innovate something. Then they should be able to make a report, write in different formats, because different organizations, different processes, different funding agencies, different industry, they may want a write-up in different formats. Maybe I want a small synopsis only, like abstract. Somebody wants a detail. So, and when the student has to write a synopsis only, abstract only, he should know what he should present. Instead of giving the stories, he should come to his own work, and he should be able to emphasize on his own work. He should be able to have the capability of problem solving and infer and communicate results. He should be able to, let's say he is doing some experimentation, he should be able to he should be able to draw inference from the results and communicate the results to the authority, whosoever is there. Maybe he's a teacher only, it may be an industry only, it may be outsider. Then teamwork. Teamwork is to work independently and collaboratively. He should be able to work as a team leader. He should be able to work as a member of the team. It may be a team from his own department, from his own course. It may be from the interdisciplinary team also, which is the now demand of the hour. Okay. I'm sure you all have gone through the Bloom's taxonomy. If not, I'll request all of you, because we have decided to be teachers. So I request all of you that you go through what is a Bloom's taxonomy and how we can use in our day-to-day teaching. Now, project work is basically the highest part of Bloom's taxonomy, level 6. So project is basically create part of Bloom's taxonomy of learning and is based on all the 5 lower levels, other levels of Bloom taxonomy. If you see, there are 6 levels. Lowest level is remember. Second level is understand. Third level is apply. Fourth level is analyze. Fifth level is evaluate. And 6th level is create. We are talking about that we should focus the project on 4, 5, and 6 level. And basically, I am talking about that it should be focusing on create level, because when we talk about the 6 levels of the Bloom's taxonomy, as we go higher, level 1 to 6, that's a level 2 will subsume level 1, level 4 will subsume level 1 to 3, and level 6 subsumes level 1, 2, 3, 4, 5. That means if somebody is doing work on create, then that means he knows all the other levels like remember, understand, apply, analyze, evaluate, and that means he will use all this. When he has to create, he will analyze also. When he has to create something, he will evaluate also. He will apply the principles which he has studied during his theory classes. Now, the aim of the student project is to develop higher level technical skills to enable them to develop solutions to complex problems, initially in their own discipline, with a target to focus on interdisciplinary and multidisciplinary disciplines. Okay. That means we start with own discipline. But as you are in the technical field, own discipline doesn't suffice these days. When you are working on a project, it will have multidisciplinary angles. You may have a person, somebody from mathematics in the team. You may have somebody from physics from the team. You may have somebody from materials in the team. Or let's say you are working on a computer, you may have somebody from the systems, some developers, some testers, and maybe a domain expert also. So basically, idea is to develop higher level technical skills or higher level technical skills, HOTS we call it. So idea is to develop that. So why do you want to do that? Because we want that whatever the student has learned, he should be able to apply in the project period so that he is very confident of what he has done, and in the process he revises all the theoretical aspects also if the project is done seriously. Now, at what stages you can have the student projects? In final year, that is called major project. Duration may be 1 year or 6 months. But the basis for this project is that the student will be able to use the learning done throughout in the program till 4th year or including 4th year. In fact, it is going beyond 4th year. What is the advanced technologies which are which are available in the market now. So he should use his own knowledge, but at the same time, what is happening in the market, that should also be known to him. He should also be able to apply that. So that means it is not limited to what you have taught. It will encourage the students for self-learning also, right? It should encourage the students to go for self-learning also. Incorporates futuristic technological developments. What are there? Maybe something he has in mind, he can implement. It can be institute-based or industry-based. You can do it in the institute, but if you can get a problem from industry, it is better. It is much better because they will work on a live problem, and there are chances of industry absorbing those students also if you can provide a solution. Primarily product-based. That means we are interested in developing a product. You see, there are two types of projects. One is called product-based, second is called just research-based, in which you do the research only and come out with a report based on the research you have done. Maybe you do the practical experimentation also in that. And evaluation by external experts, preferably from industry. That is preferred, that your major projects will be evaluated by a group of persons from industry. Okay, okay, I think I'll have to do that. Second is minor project. It is normally done in pre-final year. Duration may be limited to 1 semester. This minor project, which somebody said, Madam Chawla said, that they are going to introduce, it will be basically a 1 semester project. It incorporates learning of all the subjects covered till that time, with scope for futuristic aspects. You see, whenever you are doing something, the futuristic aspects have to be kept in mind. Unless the students are able to learn and apply futuristic technologies, they will not find employment. And if they know it, then they will have much better employment chances. Primarily, it is institute-based. They do it in the college or in their homes. Expected outcome is not a project, not a product. It is basically a project report only. Or maybe somebody can develop a small product also, but because the time is not there, you have only 1 semester, it may not be possible to come out with a product. The evaluation can be done by jointly internal and external academic experts. Then there is a course-based project, limited to the course learning. It is basically limited to what you are doing in the current course, in a particular course. Of course, you can always use learning outcomes from the other courses also to support your course. But let's say you are doing C programming subject. So you do a project on C programming only. You are working on engineering materials in mechanical engineering. So work on engineering materials project only. Duration will be semester only. It will involve, it is not may, it will involve prior learning. And evaluation is part of the course evaluation. Whatever you are doing, you don't have maybe separate evaluation for this. Then laboratory-based project. It is similar to what we have a course-based project. It is part of the course only. it involves application of the experimental knowledge you are gaining, how to use it actually. It is not only conducting the experiment, but using it. It is basically applied part of the Bloom's taxonomy. Can be done in single practical class or extended to more classes. So you may have the complete semester, or you may be allowed only in a single practical class. Evaluation is done as a part of the lab evaluation. You all of us have heard the concept of experiential learning, where the student get the practical experience of doing things. So many of the colleges, many of the universities has started experiential learning, and they do it small projects in the class itself, in the lab class, in the theory class. Wherever there is a lab class, the students will be asked to do something on experiential learning based on the experiments they are doing, why they should do it. So this is basically where you can have project. Maybe you can have a project at any time. I have seen people, they start the project in the second year and they keep continuing. That means that this project which is done at the course level, then that can be extended to the minor project, and that can be further extended to the major project. Okay. I will not call this, you are seeing this slide. This is basically the steps in the major project work. The students will be able to identify the domain for a project work and problem formulation. Let us not call it as the course outcome. Let us call these as the project activities. That means the student will be able to identify the domain for project work and problem formulation. Based on what? Based on area of interest, based on the employment avenues, based on literature survey, what others are doing, and based on who can benefit from this project. It is society or industry. We have to see that. The student will identify this. You see, this doubts needs a lot of effort on the part of the student as well as on the part of the teachers. The teacher has to be always there to mentor him. Then he has to come out with the problem. So identify the domain for project work and problem formulation. Analyze the problem to explore different alternatives to solve the problem. You see, first is defining the problem itself. He should be able to define the problem. That's also a good exercise. Then analyze the problem to explore different alternatives to solve the problem. This you will not get from any book. Now, what will you need for this? Knowledge of basic sciences, basic engineering discipline knowledge of his knowledge, technology available as on date. That means state-of-the-art solutions available. Of course, we have to see the financial aspects also. Let us forget the financial aspects at this point. Then he or she will design the proposed solution. You see, what we are talking about 21st degree skills. The 21st degree skills need innovation, creativity, problem solving, all these aspects. But when we analyze our project works, what we are doing, these are all missing. These are all missing that results into poor employment of the students because they do not know anything. Most of the students buy projects. Thanks to the big shops which has come up, they will make the project, they will make the project report also. And we are very happy as teachers so that we don't have to do anything in the project. What happens in the project? The project is allocated and the teacher forgets about the students. There is no periodic monitoring. The student comes with the project one day prior to the Viva VOC and that is all. The teacher also signs on the notebook. That is all. And the external examiner also because he's one of our friends only. When I am taking teachers, I am also a teacher. So I talk about myself also. So when he has to design the proposed solution, he should have domain knowledge. He should be able to integrate information from different subjects or areas. Selection of the tools available. That means what are the tools available? Tools means methods and processes available to develop the solution. He should know what are the norms and standards for this. What are the safety issues in this? What type of, let's say, if you do have to assembly, what sort of the fit they should be available in the meeting components. Societal and environmental issues. The project, the design which I am proposing, the students should know whether it will create any environmental issues. Will it respect the SDGs? Will have adverse effect on the society? It will need teamwork also and leadership. Maybe many more things. This is what has come to my mind, I have written. So once he has decided, based on the information, the knowledge, skill and attitude in the third column, he will design the solution. He may have alternatives here. So what he will do is, he will evaluate the alternatives. So evaluate part will come of Bloom's taxonomy. And he will give a justification of choosing a particular solution. Why not the other one? We are not doing it. We are just skipping this design stage in the project. I go for NBA visits. Every college participates in the that all-weather, all-terrain vehicle. So one of the good colleges I went. So they say, we have made this all-terrain vehicle, and we have got such and such price. I said, okay, this is very good. You have done the effort. You have been able to integrate the different technology, different things. But I said, why did you use this chain for driving? For transmission. You could have used gear drive. You could have used a belt drive, chain drive, rope drive. Why? That why was missing. This is the true story I am telling you. I asked the same students. There was a plate, thick plate. I said, what is the thickness of this? They said, 12 mm, sir. I said, why did you use 12 mm? Why not 8 mm? Maybe 8 mm will do. So they have not done the analysis. What I expected from them was, even if they have not done the analysis, or they should have told me that we did the analysis, the actual size was coming for as 9.9 mm, but availability in market is only 12 mm thick. I would have been very happy. But they were blank. They didn't know that this aspect is also to be taken care. So why will come here? in design stage. We have to see why we are doing it, why the students should do it. So, very important aspect of this is that we should question everything here. That questioning is not there in engineering now. They just copy and paste. I normally tell students that you have welded this. My technician would have done the much better welding than you have done, because it is his job. Welding is not your job. You should know what to weld and how to weld, but actual welding, I think technician will do. Because we are not questioning, we are not going into that aspect. That is why we are likely to fail. Our students are not getting the required skills which are desired by the industry. You say degree holder will not do welding. He should know how the process works, what are the parameters of the process, and how to get the best results from that. If the degree holder knows that, he is a good person for welding shop. So once you have designed it, once you have analyzed it, you have come to a particular solution and you have decided on a particular solution, you basically come out with the specifications from the design stage. All specification, dimensional, geometrical, as well as materials. Just see how much knowledge you should have at this stage. You should know about the materials, you should know about the processes, you should know about the metrology, you should know about the properties of the products, materials, everything you should know, the student should know. Then once that analysis has been done, even the student should be able to present his design at this stage, that this is the done, that is how I have analyzed, and I will present it to you so that there is a scope for improvement also. A team of teachers can evaluate that design and give some information or the suggestions. Then develop the proposed solution. The student will be able to develop process, development through the process. Evaluation of the process is also have to come here. That it can be done by welding also, it can be done by machining also. Then, you see, when you are selecting the process for development, you should know the process capabilities also. So many things the student is learning here. He knows what are the process capabilities of a particular process, how to measure it, what are the important characteristics to be measured. There are 100 parameters in a particular product. So what are the important parameters which I should measure it? Because all measurement and inspection takes time. It is basically adding to the cost. So we need to see that we have to select what all we want to measure. I wish that we could measure 100%, but we may not be measuring 100% because it is adding to the time, adding to the cost, adding to instrumentation. And safety aspects. How to make sure of the safety of the product. It may be a computer program even. How to make sure of that aspect. Then you have to evaluate the proposed solution, develop the solution. You should have the performance metrics. What are the basis for measurement? Let's say you have made a robot. Does it have the required accuracy? Does it have the required repeatability? Can it stop? Does it have the sensor which can sense a person or obstacle? Can it change the route? So what will you do? What type of setup you need for testing it? What type of instrumentation you need? Then evaluate the results. There may be some deviations which are acceptable. There may be some deviations which are not acceptable at all. So you have to redo it. Then financial aspects. That means how much cost it has done. That is what we call it as cost benefit analysis. We do it. Is it worth it? Anyway, in student project, we can forget at this stage, but if you can develop a good project, then it is acceptable. Then next is the report preparation and presentation. Soft skills coupled with domain and allied knowledge will work here. So we have to see how to put it what we have done. Documentation is very important here. And we probably are weak in documentation. Our students are weak in documentation. We have to tell them how to write it. Instead of writing essay type things, let them write in the bulleted form, point wise. And they should be able to make a presentation out of that, which they should be able to present. So that should be the aim of the major project. Any questions, please?
Excuse me, sir.
Yes, please.
Sir, myself, R.D. Umrikar from GP Ahmednagar, sir.
Yeah, please.
In this course outcome, in our curriculum of the project, we are having one more parameter in which we conduct end-term seminar, and there defense of the student is checked whether he is properly understood the concepts of the electronic circuit he has developed. So that also one course outcome we have included, sir.
Yeah, we can have in between also that presentation, and then we can have periodic, but I have written at the end this thing, presentation. We can have more presentation, periodic presentation, so that the student can be corrected wherever he is not going in the right direction. That's very good point.
Yes, sir. Yes, sir.
Yeah. Thank you, sir. Now, what are the guidelines for identification of the student project? It should be student-centered. That means most of the work should be done on the student, by the student or a group of students, and there should be a guide to guide them occasionally, to correct them, or to just counsel them, advise them on certain issues. Mostly it should be done by the students. It should be a student-centered. Let's leave this focus on attainment. I'll come to it. It is the last point also. It is repeated. The project should integrate the learning through courses taught. Whatever courses have been taught by now, and of course, futuristic approach it should have. It should integrate the futuristic technologies also. They should use the available tools, whatever tools are there. Let's say in mechanical engineering, we say CAD/CAM tools, right? Similarly, there are tools in all disciplines. They should use. They should know actually what are the tools available and how these tools can be used in their project work. And it should be application oriented. Application of the knowledge which the students have gained through theory and practice. Current technology inputs and futuristic in nature, both. The students can work on product improvement also. If there is already an existing product, they can work on product improvement also, if possible. Last is they should contribute towards attainment of program outcomes. They should contribute towards attainment of program outcomes. You know what are the program outcomes? If you see what are the program outcomes, okay, let me just show you the program outcomes. You may be knowing. For engineering degree programs, these are the program outcomes. Just go through it. Let us go through it, please. First is engineering knowledge, talking about the basic sciences, basic engineering, problem analysis, design, development of solutions, conduct investigations, modern tool uses, engineer and society. Next, environment and sustainability, ethics, individual and teamwork, communication, lifelong learning, project management and finance. So I have tried to integrate all these into my outcomes because I have compressed. I have integrated more than one PO into COs. That is, the project should contribute to all the POs which I have shown you. Okay, this I have done. The project identification should be based on the student interest. Students should be interested in that, or a team of students. It is normally not student, it is a team of students. So you have to form a team and see their interests. Project duration. What is the duration of the project? Is it 1 year? It is one semester? It is 1 week only? What is the project? So what I mean here is that it should be doable in the given period. Whatever period is given, it should be doable in that. You should be able to complete it. Focus area you should see. There are focus areas for a particular time. Let's say these days, there's a lot of people are talking about artificial intelligence, machine learning. It is not only that computer people will do only machine learning. Mechanical people will also do. Civil engineering people will also do. In mechanical engineering, there is a lot of stress on additive manufacturing. Civil engineers also do it. Computer engineers also do it. So let us see what is the focus area where there are jobs available, employment available. Utility, will there be any takers for this project? If somebody can take your project, somebody can help in your project, then it will nothing like that. Guidance availability. Is proper guidance available for this? It should not happen that the students start doing it and nobody is there to guide them. Resources availability. What are the resources available on this? You want to do something on additive manufacturing and you don't have a machine. You don't have a machine in the nearby area also. Budget. What is the budget available? Do we have the financial resources? Does your college support something? Can you get a project from outside? Can you get some funding for that? That teachers also, of course, have to do. So this should be based on this. Maybe there are other areas also. So the project should focus on a good cause and address issues at the local, national, or international levels. The project should be such that it allows students to be creative and find innovative solutions. Keep the audience in mind when writing the project. When deciding on the project, let us see who will be the user for this. It is not only for the curriculum's sake, or can we go beyond that? Can we think that we will take it ahead in the next year? Timeline, as I said, duration of the project has to be kept in mind. Now this, I have written one more line. Specific topic is easier to cover in depth than a broad topic. You should narrow down on a topic. It is not saying that you restrict to a particular subject only. Topic should be narrowed down. And I want to work in bioengineering only. I want to develop a solution for biomedical application. So let us see. Then I will need to know many things about medical also. But I am not going to steam engine. If I am working on machine learning, okay, I'll forget many other things. Consider what new skills students learn and what they want to learn next. What are the new skills which they already have, and what they will do, what they will learn while after they are completing the project. So as far as selecting the project, I have given you some ideas. Anybody wanting to discuss on this? Okay. When you have to plan for the subject, do planning for implementing whatever you have decided. So planning students' project work effectively involves several key steps to ensure that the project is well organized and achievable. So some steps I have taken from the internet only. One is define the project scope and what will be the end result you want. Define the project scope and goals. Okay, I'll just, because in the next slide it is again discussed. Break down the project into tasks. Create a timeline. Unless you have the target, you will not be able to, the students will not be able to be doing it seriously. Assign roles and responsibility to the team members. Very clearly assign the roles and responsibility to the team members. Otherwise, what happens? One or two students end up doing the project, rest of them are not doing anything. Assign roles and responsibilities to each team member. Decide on the resources, what resources you will need, and try to collect those resources. Develop a communication plan, how you will communicate with each other, how often the team will meet, how often the team will share the experiences, how will be the mentoring available, when will the teacher or a group of teachers meet with the students, like one of my friends from Allahabad said that they have a presentation in between. See what are the potential challenges, what can happen, what can hold you from completing the project, so that you can think of alternatives. And very important is that you document the process. So let's come to the next slide. Define the project scope and goals. Clearly outline what the project aims to achieve. If you know what the project is expected to achieve, what I normally say, it is half done. If you know where to stop, it is half done. If you are working on a project without knowing where you want to reach, that is not going to finish, because the target is not known to us. Then set specific, measurable, achievable, relevant, and time-bound goals. Set the goals which can be achieved based on the time duration, based on the skills of the students, based on the resources available, and how to measure those goals. It should be very specific. Second step says break down the project into tasks. It is a big thing. Project may be a bigger thing, but you break down into different tasks. That first we will do this, first we will do next, like that, and include the measurement and testing into the each stage if it is required. Organize the tasks into manageable phases. Link these subcomponents with the time frame. Create a time frame. Assign due dates for each task and phase. Develop a project schedule that includes all deadlines and key milestones. Because unless you know what are my target lines, what are the timelines I have to meet, probably people don't take it seriously. So if there is always that chart is available to you that I have to complete this, the students will also be serious and they'll try to complete the assigned tasks But the teacher, the guide, the group of teachers, they have to ensure that they also monitor the timelines. As I earlier said, assign roles and responsibilities, determine who will be responsible for each task, ensure that each team member knows their role and what is expected of each. Document it. Let everybody know it. Who is responsible for what. I should know what I am responsible for. At the same time, others should also know that I am responsible for this. That means if particular item has to be done, everybody should know that he will do it. Resources, identify tools, materials, information needed for the project. And try that, ensure that all are available before you start. If they are not available, find out where they are available so that you can request somebody. You want to do some microscopy, ask somebody, sir, we will use your facilities. Develop a communication plan. Establish how and when the team will communicate, that I talked about you. Set up regular check-ins to monitor progress and address any issues. Very important part. You do whatever you want. You have the resources, you have the timelines, you have the subtasks, you have the team. Unless you are meeting time to time, it is not going to help. Plan for potential challenges. Identify possible obstacles and develop contingency plans. You should have what we say is plan B ready for this, for each step. And be prepared to adjust the plan as needed to accommodate changes. If the changes have to be done, it will need time. So how to adjust the time? You should not be jumping the timeline. Then document the process. Keep a project journal or portfolio to document progress, challenges and learning experiences. This helps in reflecting on the project, improving future planning. So this is how you can plan this. As I said, there should be a regular monitoring and you should have an evaluation plan also. Just when I was sitting on this, I wrote some just small projects which can be used for experiential learning. These are just out of mind only. Please don't take them seriously. You can add your own projects into this. What I wanted is digitization of laboratory experiment with an aim to convert mechanical displays into digital displays. If some students can do when studying mechanical measurements or digital vision systems, then they can be asked, or vision system or digital display system, they can be asked that, okay, let's come and replace all the mechanical displays, gauges and all with digital display. To develop IoT-based hardware and application for lab experiments. You see, coming back to experiment number 1, this experience number 1. Once I have made it digital, let us put it on IoT and let me take the display on my laptop or computer, mobile. Next is to monitor the motion of a moving article and apply correction to make it reach a predetermined destination. This is basically a like something like automated guided vehicle. That means you make it, and if there are any changes, deviation from the given path, you correct it. You can have a smart vehicle also. To analyze the microstructure of metal sample and link it to mobile application or to a system through IoT. To develop an application to suggest a mixture of elements for desired mechanical properties of a metal. Let's say you want to make a composite. What should be the mixture of the different materials, or you can make a alloy. What should be the percentage of different materials, or what should be the components of the alloy itself, so that I get the desired properties. To control the speed of a machine based on surface roughness. You want to have a particular value of surface roughness, what should be the cutting parameters. To predict the life of a bearing based on some indirect measurement. Bearings basically are concealed in the body of the machine. So you cannot measure anything. Can we have something in direct measurement system so that you know that this bearing is going to fail? To switch on off AC based on occupancy. If people are there, one AC should be there working. If there are more people, two AC should be working like that. To make an electronic counter to count the number of persons passing through a door without counting the person going in other direction. Like you have this at many venues where we have rallies and all, there you are there counting people, but they are simple counters. They if the person comes into the other direction, it comes out, that also is counted. So I have made it that okay, the person who is going in the other direction, they should not be counted. They should be taken out. To reverse the direction of a motor, to calculate the number of rotation of electrical motor required for a given linear motion of an object, to convert rotary motion to linear motion with display of RPM and linear movement, to convert rotary motion to angular motion with display of RPM and angular movement, develop a LVDT, linear variable some transformer for linear measurements, to develop an automated XY table. That means whatever angle you want, it should rotate. So these are some of the projects. These cannot be the major projects, but these can be smaller projects which can be assigned to the student, and which can be, there will be a lot of learning out of this. Now I am just going to run a small movie which I have taken from YouTube. Is it visible?
Yes, sir.
Only 4 minutes, please. Let's say you want to make a automated door lock with fingerprint sensor, fingerprint sensor.
एक्सक्यूज मी सर सर अब इसमें इसकी ना ऑडियो नहीं आ रही है
हाँ, ऑडियो नहीं आ रही.
नहीं सर
Anyway,
ऑडियो नहीं आ
there is
रही
nothing to say. Just watch it. No problem. If audio is not there.
ओके ओके सर
I just wanted to show you that what can be done. It is available on internet, and if our students repeat this in a small, let's say in the class projects, uh, they will learn many things: how to select the material, how to program Arduino, how to make it work. So all this we can with the small this thing. Small experiment with a small project, we have been able to teach them. So, any questions from your side, please? Yes, Madam Chawla, you have any question? Parul Chawla?
No, sir, no questions. I am just listening, sir. Actually, you are explaining the things by the example of uh, uh, what you are using words like टेक्निकल जो आपका रहता है ना कि हम लोग मैनेजमेंट से हैं तो कुछ वर्ड अगर एग्जांपल उससे रिलेटेड होते तो इंटरेस्ट ज्यादा क्रिएट हो जाता है
मैनेजमेंट में मैडम वी हैव नॉर्मली प्रोडक्ट टाइप नहीं होती, नॉर्मली आपकी रिसर्च टाइप प्रॉब्लम होती हैं. If your product is that will, let's say you want to make something on supply chain management, you want to make a model. That you can ask the students to do it, but you can interpolate. So I presume that it is basically a technical group, but similar guidelines will be available that has to be implemented in your case also. I agree that I have been talking technical only, but there is a document with me which says if there is a research project, you want to take out the outcome, what should be there. Similar things will be there. The only thing is that they should be able to do their this literature survey. They should be able to find out some gaps. There should be some inferences drawn from the literature. Then they should design a questionnaire. They should be able to collect information. They should be able to analyze. If you can have something on data analytics, they should be able to present, make a report, and they should be able to present it. That is what we expect.
Behavior also. We do researches on behavior, human behaviors. So
yeah, it will be then when you are in HR and all, you will have to have that type of projects only. Yeah.
okay.
Differently,
So
but you would need to have a documented and systematic approach.
Depend upon the topic on which I actually want to explore our experience. No?
Mr. Anil Reval has another objection. He says due to the lack of faculty, availability of faculty, we have to do some maybe some compromises somewhere. That cannot be helped because when the faculty is overloaded. But even then, we try to we try that we meet the requirements of the program so that the students do not suffer. We probably do some more work, extra work. Anil, thank you for raising this issue. Yes, Rajesh Murikar.
Sir, in our institute, our students third year.
First, tell me what is your institute?
Government Polytechnic Ahmednagar, sir.
Okay, Ahmednagar.
So there is one state level project competition called DPEX. So in that DPEX competition, our students participated. At that time, we all together do that what you are taught, that project management work. So we guide students, and every year our students at least get some prize, sir, in that.
I'm happy that you said that you are also using similar methodology what I have discussed.
Yes, sir. Yes, sir.
You can have a project competition where you can keep small prizes. I don't know, government polytechnic cannot give prizes. Somebody can be asked to sponsor the prizes, small prizes, 1,000 rupees, 2,000 rupees for the project.
This JMSBT, our Maharashtra State Board every year conducts project competition, and this year our student has got 50,000 second prize, sir.
Oh, good.
Yes, sir. So
Good,
he has
good.
developed a very nice project, sir. That Chandrayaan that was failed in first attempt. So what could he have done to prevent that? So he had some innovative idea about that, and he got second prize for that, sir.
Okay, okay, Rajesh. Thank you for.
Yes, sir. Thank you, sir. Thank you.
So, ठीक है. Now, there are no questions. We will close it here. Thank you very much. Thank you for listening, and I'm happy that you are already doing it.
Thank you, sir.
Thank you very much.